So this is going to be a brief tutorial of the action potential. We already have learned that the cell at rest is at -70 millivolts due to two forces, electrostatic pressure and diffusion. So really we want to review, how does the brain make the body move? And in this very simple preparation right here, we have the axon of a giant axon of a squid. And so something to note, unlike a human nerve, this axon is not myelinated. And so our action potentials are being propagated in the nodes of Ranvier down our axons, but this is a naked axon. And so up here we have a stimulator, a piece of equipment that will stimulate and put current into this squid axon. And right here, this is our oscilloscope, and what I want to point out is that this graphical function of time is displaying an action potential. So we're going to review briefly how we go from the resting membrane potential to being able to see an action potential. And so if we think about our neurons and how they're connected, so here we have our presynaptic neuron and here's our postsynaptic neuron, and a blow up of the synaptic space. With this electrochemical detection, this postsynaptic neuron here will get depolarized enough to fire and to have an action potential. So I'm going to draw what's happening during our action potential. So we have time on our x, and this is in milliseconds. So this is a very fast event. So it's usually between 4 and 5 milliseconds. So we'll put our scale here up to 5. And then we are measuring our y-axis in millivolts. And as we mentioned before, our neurons at rest are at -70. So we'll find our neuron at rest. So we'll put -70 here. I'm going to put some other values. And note, we're going into the positive range here. So we are negative below 0, and here we're about 40 millivolts. So if our neuron is at rest, we can actually just graph it straight if we were to stick an electrode into that squid axon. And as sodium rushes in, we'll start to polarize. We're going to really depolarize. And in this phase here, we have sodium rushing into the cell, so sodium channels are opening. And as sodium continues to rush into the cell, we are going to continue to depolarize until we pass 0. And right around this time, we start to have our potassium channels opening up, and we're having potassium leave our cell. And right around 40, our sodium channels are going to enter they're going to shut and begin to enter a refractory period. And this is going to be one of the reasons why we start to repolarize. So we're getting, again, closer back to 0. And sodium is still leaving the cell. And what happens is so much sodium leaves the cell, we end up hyperpolarizing. So if I were to just draw a line here, we would see that this hyperpolarizing period is below our resting period of -70. So now I can say that this area here is my depolarizing phase. This is my repolarizing. And this is my hyperpolarizing phase. So I am below -70. And eventually we'll get back to rest at -70, and the process can happen over again.